How does atmospheric propagation affect Air Force directed energy weapons? Imagine aiming a laser at a distant target and knowing that the air between you and the target can influence the effectiveness of your weapon. This is a critical consideration for the deployment of directed energy weapons by the Air Force, which relying on concentrated electromagnetic energy to neutralize threats. The atmosphere is a complex medium that can significantly alter how these beams travel and deliver their destructive power. One of the primary factors affecting atmospheric propagation is the presence of particles and molecules in the air. These include water vapor, dust, smoke, and various aerosols. When a directed energy beam passes through such particles, it can experience scattering, which disperses the energy in different directions. This scattering reduces the intensity of the beam reaching the target, thereby decreasing its effectiveness. For example, fog and heavy rain can cause substantial scattering, making it difficult for laser beams to maintain focus over long distances. Absorption is another critical aspect. Different atmospheric constituents absorb specific wavelengths of electromagnetic radiation. Water vapor and carbon dioxide are notable absorbers in certain parts of the electromagnetic spectrum. If a laser operates at a wavelength that coincides with an absorption band of water vapor, the beam's energy can be absorbed before reaching the target, diminishing its power. This absorption can vary with weather conditions, altitude, and humidity levels, requiring careful selection of laser wavelengths for optimal performance. Refraction, the bending of light as it passes through layers of air with different densities, also influences beam propagation. Temperature gradients in the atmosphere create variations in air density, which can cause the laser beam to bend slightly off course. Over long distances, this bending can lead to misalignment with the target, reducing the energy delivered precisely where intended. This effect is more pronounced in environments with significant temperature differences between the ground and higher altitudes. Atmospheric turbulence, caused by irregular temperature and pressure fluctuations, introduces another layer of complexity. Turbulence causes rapid changes in the refractive index of air, leading to beam distortion and spreading. This phenomenon, often called beam wandering, can cause the laser to drift from its intended path, decreasing the concentration of energy on the target and potentially reducing the weapon's effectiveness. To counteract these atmospheric effects, the Air Force employs adaptive optics systems that adjust the laser's focus and direction in real time. These systems analyze the atmospheric conditions and make rapid corrections to maintain beam quality. Additionally, selecting optimal wavelengths less affected by atmospheric absorption and scattering enhances the reliability of directed energy weapons under varying weather conditions. In summary, atmospheric propagation plays a vital role in the performance of Air Force directed energy weapons. Factors such as scattering, absorption, refraction, and turbulence can all influence how effectively a laser beam reaches and impacts its target. Understanding and mitigating these effects through advanced technology and strategic planning are essential for maximizing the potential of directed energy systems in operational environments.